Welcome to Maintaining a Secure and Updated Edge with Insight Director of Technical Architecture, Connected Workforce, Joe Flynn, and Insight Product Manager of Connected Workforce Portfolio Services, Chris McCoy.
Hello, everyone, and thanks for making time to join our breakout session on maintaining a secure and updated intelligent IoT edge, which is really about Insight's approach to managing intelligent edge devices in the enterprise. I know many of you are very familiar with the challenges and benefits of deploying intelligent edge devices and technologies in your environments. So our hope is today that we can educate you on our approach and how we might be able to help support your organization realize the benefits of not only the technology, but working with Insight as well. So as far as an introduction, a little bit about myself. My name's Chris McCoy, and I'm the product manager responsible for device and endpoint management service offerings with Insight's Connected Workforce Solutions Group. So as my bio states, I've been in the technology industry for over 20 years and have specific experience and expertise with end user computing, VDI, device enablement, and endpoint management.
Good afternoon, good morning, everybody. My name is Joseph Flynn, Services Director at Insight over the Connected Workforce Digital Workplace domain. My group and role are responsible for new services, new technologies, and the value that we could bring you as the customer from an ongoing technology aspect, but also business aspect. Nice to meet everybody.
Great. So perhaps the best place to start is truly understanding what is the intelligent edge and what does an intelligent edge device do? What's the difference between an intelligent edge device and a standard IoT device? And more importantly, how do they all work together? So how do we define the intelligent edge? What does this term really signify or mean? Well, for the most part, the intelligent edge is a process where data is analyzed and aggregated at a point close to where it's captured in the network. So what does that mean? So it means that if we think of the intelligent edge as a place and not a thing, we can understand it as a place where the data is collected. It's a manufacturing floor. It's a college campus. It's a utility power plant. It's a place where devices such as cameras and sensors are in use and being monitored by intelligent edge devices and being measured, controlled, analyzed, or processed. From a device perspective, an IoT device can be any device that can connect to a network or relay or interact with other devices. These devices usually have limited processing capabilities, limited resources, and usually a singular function. So these devices may include things like scanners, cameras, sensors, lighting systems, speakers, utility machines, other locks, power transformers, really anything that has a function and interacts with other devices via a network connection. So if that's an IoT device, what makes something an intelligent edge device? So perhaps the best place to start in truly understanding what is the intelligent edge and what does an intelligent device do? What's the difference between an intelligent edge device and a standard IoT device? And more importantly, how do they all work together? So how do we define the intelligent edge? What does that term really signify or even mean? For the most part, an intelligent edge device and that process is where data is analyzed and aggregated at a point close to where it's captured in the network. So what does that mean? It means that if we think of the intelligent edge as a place and not a thing, we can understand it as a place where the data is collected. It's a manufacturing floor, it's a college campus, it's a utility power plant. It's a place where devices such as cameras and sensors are in use and being monitored by an intelligent edge device to be measured, controlled, analyzed, or processed. From a device perspective, an IoT device can really be any device that connects to a network and relays or interacts with other devices. So these devices usually have limited processing capabilities, limited resources, and usually a singular function. So these devices can include scanners, cameras, sensors, lighting systems, speakers, anything in the utility like machine, transformers, locks, powers, devices, anything that has a function and interacts with other devices via network connection. So if that's an IoT device, what makes something an intelligent edge device? So I think it's helpful to think of intelligent edge devices as really responsible for three primary functions. One, to connect or to act as a gateway to the cloud, meaning when devices, people, or things connect via networks, it facilitates data exchange. Two, to compute, right? So the brains of the IoT solution, meaning edge devices compute data, provide access to applications, they reveal insights concerning the connected IoT devices. And then 3, to control, right? Or initiate actions, meaning these computed insights can then be used to take action, control these IoT devices, or control actions associated with the environment. From a device perspective, these functions can scale from lower end gateways all the way to powerful rack-based data center solutions. From a workflow perspective, how do these devices support the IoT workflow? Let's use an example. So in a secure office building, a facial recognition camera that's acting as an IoT device recognizes a person, and the IoT edge device receives the data, interacts with an application that can match the identity of the person and confirm security and access levels, then interacts with other applications that control lighting, air conditioning, and automated door locks. So the person can freely walk about their workplace. Another specific example, a temperature sensor and a door sensor are placed inside a walk-in refrigerator. If the temperature rises above a certain level, or the door sensor indicates that the door's been left open, the intelligent edge device can interact with the sensors, collect data, and interact with the collaboration application to notify the manager that, hey, the door's been left open and the refrigerator might not be cooling properly. So those are the types of workflows that we can see within the environment. Now that we know what an intelligent device is and what it does, why is it important? So collecting, analyzing, computing, processing data close to the source enables faster and quicker actions, improving business process and time to result. Intelligent edge devices can continue to monitor and function despite losing connection to the internet, creating some redundancy and continuity of operations. Intelligent edge devices enable better and more efficient data aggregation to the cloud-based compute resources, as well as improving time to result, such as a sensor detecting seismic waves during drilling operations for an oil well. Enhanced computational capabilities allow for onboard analytics and AI, which further enable advanced capabilities such as a vision-guided robot on a manufacturing floor. And intelligent edge devices provide better management of device protocols and applications within cloud-based resources. So like a traffic cop, it directs, aggregates, and coordinates workflows. So what does the industry say, or more importantly, what does Gartner say about the intelligent edge? So according to Gartner, there's significant need to provide professional and managed services for customers looking to deploy intelligent edge solutions. In fact, they say from now through 2022, over 50% of all edge computing solutions that worked as a POC will fail as production deployments, which makes working with a qualified and experienced partner essential for success. Utilization of low-code and no-code tools will be a significant factor in development of more than 20% of new edge applications, which will empower citizen developers, meaning that custom tools will likely fall to the wayside for more broadly applicable and accessible platforms. And this is important as it leads to greater ease of automation and administration. The advancement of tiny machine learning, or TML, will likely help drive greater capabilities in lower power, lower resource devices, increasing the scale of workloads and capacity for intelligent edge devices. And then Gartner also predicts by 2025, more than 50% of all data analysis will occur at the point of capture on an intelligent edge system. That's really important as it shows a huge shift to the edge, and that more than 60% of all security cameras, all monitoring systems will ship with analytics capabilities embedded. So embedded intelligent edge devices will be growing as well. So you can see a tremendous market. So now that we understand what the intelligent edge is, its capabilities, and the importance of adopting an intelligent edge strategy, it's equally as important to understand some of the common challenges associated with implementation and administration of the environment. From a complexity perspective, management of the intelligent edge devices can create some complexity in terms of administration of the device and the data workflow. It's essential that devices are properly enrolled into a monitoring solution that can provide updates and patches for various operating systems, specifically Windows, Linux, and iOS-based devices. Without effective remote management, even the most skilled personnel are not going to be able to deploy or manage the environment with any regularity. From a security perspective, it's very important that we look at a couple different considerations. These considerations include secure communications from the data center to the edge device, securing devices against breaches, securing privacy of data through the workflow, as well as having the ability to detect and stop rogue devices from entering the environment and collecting sensitive data. From a resources perspective, edge devices pose logistical difficulties in terms of deploying an actual human IT resource to manage them. Most companies can't have a dedicated admin to monitor and service each and every edge device location. So, for example, organizations can't deploy a dedicated admin to service a sensor or a gateway or an aggregator or a computational edge device located in every oil well, manufacturing line, or water valve. So again, trained admins and monitoring solutions are needed to properly manage the environment. Additionally, with so much additional data being transmitted over various networks, improvements in the network infrastructure will likely be needed to eliminate latency issues and ensure that the performance is optimal. From a support perspective, in addition to the logistical support issues that we've already mentioned, having reliable tools and those administrators and a support process in place to monitor alerts and keep devices in the environment updated in patching firmware to these devices as well, it's really critical to success. Otherwise, existing troubleshooting and support processes will likely be inefficient. And then finally, from a cost perspective, in addition to the actual edge devices, there are hard costs associated, right? So in terms of strengthening infrastructure, including the bandwidth and network capabilities, cloud resources, AI resources and capabilities, computational resources, storage capacity, additional costs associated with security. And then additionally, it's also important to understand the true cost of the monitoring and the alerting and the administering and supporting of the edge environment as well. So that's it for me. I'm going to hand it over to Joe, and he's going to talk about some of these areas in greater detail.
Thank you, Chris. And as we get into the device complexity of an IoT edge device, let's start with the different device types. Now, IoT edge can be consumer level devices. As many of you may be aware, Raspberry Pi devices are used a lot of times for IoT devices, could also be leveraged for IoT edge, especially if you're just passing data. But when you pick a device, one of the things you have to understand is, what is the device going to do? As the critical nature of that device increases and you start getting into things like analytics, rules engines, data normalization, let's not forget the IoT edge application itself, you may want to start looking at edge devices that are more enterprise grade, like from a Lenovo, HP, Dell, or the likes of many others, instead of going with the consumer grade. The other thing that comes into play when you start going increased cost in some of these IoT edge devices is supportability of the device. Lower cost devices seem to have a support time frame that is much shorter, unfortunately, than the higher end devices. Once you pass the device choice itself, then we have to get into the operating system. Many edge devices are Linux-based systems. Microsoft is available. Microsoft does have the IoT core for IoT edge devices from running a Windows perspective. But recently, Microsoft released eFlow, which allows you to run a Linux-based container for IoT edge on a Windows operating system. And the reason why they did this is most organizations are comfortable supporting a Windows environment. They're not comfortable supporting Linux. In fact, it's probably new to many organizations. So being able to run a Linux container on a Windows machine gives you the ability from a support organization to handle the same methodology you do on the Windows side, but at least getting access to the device and being able to perform more administrative methods on the Linux device more closely to where the OS is sitting. Microsoft also recommends best practice of actually running Linux in a container on a Windows device for IoT Edge. They actually, best practice, don't recommend running IoT Edge on Windows at all. They prefer the Linux containers because you can have more granular control and more capabilities from a Linux perspective regarding IoT Edge than you would for Windows. Now, as we get into the security aspects, Chris mentioned a few things on security, but let's dig into a couple areas where I like to drive from an OS security perspective. Authorization, let's just start, right? We want to run in role-based access control or least privilege model for devices, modules, and actors or users, and how you're handling application on the device. But then we get into attestation. For attestation, we have three methods: static, runtime, and software. So from a static, that's the boot up attestation. It's the secure boot, many of you know from a laptop, desktop perspective, and even from a server side today, where it's securing and managing the security upon the boot process of the device getting into the operating system. But once the boot process is actually maintained and complete, then we get into the runtime attestation, where we have the detection of malware and unauthorized changes of the device and on the operating system side. Lastly, we have the software attestation. That is patches and upgrades. So many of you are aware, Windows releases patches every month. Linux has their vulnerabilities and releases security patches, but also bug fixes. So you have to be able to account for how are you going to maintain those patches going forward on a regular basis. Ideally, it should be routine, it should be monthly. Depending on the critical nature of your IoT edge device, some people may actually think of doing it quarterly. But again, always have to understand what is your methodology and framework that you're going to use to be able to maintain that device going forward. Next, we want to get into more of the hardware trust certification. With the device possibly being physically accessed, we want hardware security, as it tends to be the last defense of protection. So tamper resistance at the hardware layer is critical. You want to make sure you support devices or use devices that support things like TPM, a trusted platform module for encryption and other methods, or SGX, software guard extensions. And then lastly, when we get into it, is the certification of the device. When you get into the consumer side of things from a physical device, when we get into the certification of the device, the larger OEMs certify devices on the secure aspects of it. So again, like the TPM modules, other aspects from a security nature of the device. In the consumer side, for instance, like a Raspberry Pi, it's going to be on you to hope you can secure it to meet your business requirements. So that's where the benefit sometimes goes of going with a larger OEM or a more higher end device that is communicated that they complete certain certification processes across the device and the OS. Lastly is extensibility. The ability to provide secure services like device provisioning or third-party managed services. You don't want to lock yourself into a device that you're never going to be able to access, or the means of accessing that device is going to be quite difficult. And if anything, cost you more to handle long-term. Now, as we lead into extensibility, this also leads into the requirements for alerting. So if you think of alerting based on the OS and platform you choose, will determine how and what you monitor. We both know VMware and Microsoft Endpoint Manager can handle Windows very perfectly well. As far as the management aspect, deploying patches, deploying configurations, they have that set. But when it comes to Linux, neither of them can do it, but we do know both manufacturers are driving towards managing Linux. But managing is just one part of IoT edge devices. You still have to monitor. Depending on the critical nature of that device, you're going to want to monitor processes, possibly if it's Linux, daemons, and other aspects of it to make sure that the IoT edge application is running all the time. So you're capturing rules, you're capturing analytics, and the data is being passed to the cloud. Now, RMM tools, remote monitoring and management tools like a Kaseya or an N-Central are very common for this scenario. They tend to support many operating systems. They can do both the monitoring and the management, including pushing out patches or security configurations of the device. Now, how do we treat these? I mean, you ask yourself, are they servers or are they endpoints? They're both. I mean, keep in mind, we can, depending on the device and what it's doing, you can actually just have a basic Windows laptop running, or you can have a Windows server running, depending on the critical nature. So they can definitely be both, but again, you're going to want to determine what the device is doing to understand what platform you want to do going forward. Should I treat them like a server or an endpoint? Again, the answer is yes. Based on what it's doing, you're going to have both. Okay, these devices can run on, like I said previously, on a server operating system or endpoint operating system, but they also are their own category. You're going to have to manage them differently. You're going to have to secure them differently. These are sitting on the edge more differently than most of your endpoints are today. They're going to be accessing data internally. So you want to make sure you secure it so there's no data breaches, because who knows the data it's collecting from camera to temperature sensors to other things within your organization. You don't want that data getting out. And then lastly, do I need to secure them differently than servers or endpoints? Absolutely. These are a security threat vector, so it's important you treat them like a zero trust endpoint. But keep in mind, these devices, as hardened as they have to be secure, they still need to be able to access the IoT application, possibly in the cloud that you're sending data to, but also the IoT devices within your organization that you're going to be collecting data to and performing actions based on those devices. Now, when we summarize the past few slides, you see here standardization is key. So when we look at the hardware side, if you standardize on the hardware, you have the ability to not only standardize on the device, but standardize on the everyday support and also the securing of that device in a consistent manner. By standardizing on hardware, you can build out a provisioning process that's easily to deploy new devices or replace existing devices, but also create a methodology of how you're going to support both in and out of band management. Out of band meaning possibly the device is turned off and you still need to access it. But standardizing that device gives you a clear path of how to handle that going forward. And lastly, when we get into the operating systems, the flow is the same from the device side. If you standardize on a Windows or a Linux-based, it drives into the methodology and the framework that you're going to do going forward. How are you going to secure it? How are you going to provide role-based access control? How are you going to handle the provisioning process and the daily updates and security and maintaining it going forward? Also to mention, you want to pick an OS that's going to give you a longer shelf life. At Linux side of the world tends to definitely be supported more years than what a Windows is without extended support. And on the device side, it flows the same. You want to make sure you pick a device, not a very consumer or low entry-level device like a desktop or a laptop that within 2 years it's going to be out of date. Maybe you want that higher-end device that's going to possibly be supported in 3, 4, 5 years from now, so you don't have to worry about switching it out. You ideally just have to worry about the day-to-day maintaining of the device, the security on the device, and obviously the OS of the device.
Great insights, Joe. Appreciate it. So that kind of leads us into, so how can Insight help, right? So Insight can help with every aspect of architecting, developing, implementing, and managing your intelligent edge environment. We can help ensure image consistency, updates, monitoring via our comprehensive pre-deployment lab services and endpoint management services for intelligent edge. From a pre-deployment perspective, we can ensure that the OS device image is properly configured prior to deployment. We can provide consistent updates on device and system operating systems. We can secure and harden the OS prior to deployment, as well as providing customized provisioning of your edge devices before they even ship to you. Through our managed endpoint intelligent edge managed service, we can provide monitoring and alerting of the device resources. We can also provide monitoring and alerting of outages, as well as proactively deploy OS updates and patches. And we can also ensure that the latest device firmware is updated and available to make sure that that device functionality is updated and can provide peak performance. So how to get started. Once we begin to consult with you on an IoT approach, we'll perform an envisioning workshop where Insight professionals will help you identify specific requirements, workflows, use cases to help develop a complete vision of your intelligent edge environment. From an enablement perspective, we'll work with our lab teams to create and develop secure image process for your IoT edge devices, as well as an enrollment to our managed endpoint monitoring solution and service. We'll help you plan deployment via our professional services from our digital innovation and connected workforce solutions group to help you scale and deploy your intelligent edge environment. And then we'll also monitor, operate, and improve by providing ongoing expert administration and support for monitoring and updating of devices, along with proactive technology updates to continuously improve the technology performance and service delivery. So I want to thank you all for joining us today. That's all we have. We look forward to engaging with you and helping you with your business needs.
Thank you, everybody.